Hello, Dr. Ron England here, and today we're going to talk about writing good functions. Not just writing functions in programming, but writing good functions, because I know everybody wants to write good functions. So if you're going to write good functions, let's first talk about why we write functions in the first place. So one of the great things that functions do is they allow you to organize your code. In other words, you can take things that you do and stick them inside of in this case, a box. Now, the box that you've got here is a box that does something. So you throw in all these variables, we'll say variables that you've passed to the function, and then the function's going to do something with them, and it may or may not give you something back. Now, it's still going to do something. That's the purpose of the function. It does something. And when we talk about it may or may not give you something back, we can look at that kind of by example. So let's look at a function here. Now we know that there's reasons to write a function, and before we go in here, let's go one other thing. Another reason to write the functions is so that you've got the reusability of pieces of code, that they're in a function and I can easily just call them, I can reuse them, I can stick them in libraries, I can bring them up in my file and then use them over and over again. So let's talk about writing a good function. First, the function should have a purpose, and it should really have a clearly defined purpose. Now, a lot of argumentation goes into arguments go into how much should you document this. Well, if the function itself documents itself, which it can do, then the level of documentation that you need becomes less. So for example, we're going to take this function here, def calculate volume. Okay, well, you know what? I'm kind of pretty sure that what the function's purpose is to calculate the volume. And notice I used a verb, calculate. Okay, it calculates. I know that there's going to be a calculation going on in this function. Then let's look at something else. The input should be clearly defined. All right, so in this case, there are three inputs, P underscore ATM, N underscore moles, and T underscore Kelvin. Now, I could have just made it P, N, and T, but here comes another situation. P, N, and T are actually numbers, and they're numbers with units. If you're an engineer, you need to immediately stop thinking of numbers as just numbers. Sure, there are things that are just numbers, but most of the numbers you deal with are not just numbers. They're measurements of something. And measurements of something have a number and a unit. Now, what this tells me, though, is that the pressure that you're passing to this function is in atmospheres. The N that you're passing is in moles, and the T that you're passing is in Kelvin. It's self-documenting. Now, the first line of this is a comment that says returns volume in liters. Now, I could have self-documented. I could have actually said def calculate volume in liters, and that would have done it. But of course, that would have let you demonstrate two different ways of getting documentation in there. And notice that I'm redundant here, that I actually have the three values that are passed over, and it tells you that those three exist. And then it does the calculation, and then it returns the result. So in other words, when I go ahead and take this and I highlight it and I control enter it, that is now in memory, but that function now exists. Now let's look at how we might want to use it. So in this case, I'm going to say, okay, I'm going to set the temperature equal to 273. I could have done it 273.15. Okay, but if, I'm rounding down to the nearest integer. And then I have pressure, which is an array. The P here is an array. And then I have a volume, which is an empty array. So if I wanted to go through my array of P and calculate the volume, which will in this case be V, I simply can do for little p and big P. I could use anything here. Little p is fine. And then I say V, big V, dot append, calculate volume, P, N, and T. And if I hide all this, it'll go ahead and loop through. And if I print those two, the pressures and the volumes, I can see over here that it started with the pressures that I defined, and the volumes were then calculated, and those were appended to the array V. And so the pressures and the volumes go together with that calculation. All right, so we've written a function. We've got the input We've got the output. The output is actually fairly well defined. The function has a clear purpose. Now, I'm going to go through a few things that you can do that are kind of neat here. I can give the function default values. So I'm going to set the atmospheric pressure by default. I'm going to set that equal to 1. The atmosphere, I'm going to set the number of moles to 1. And I'm going to set the temperature in Kelvin equal to 273, which is basically 0 Celsius. So I can now redefine this. And I'm going to go ahead and do I'm going to go ahead and execute the entire thing. And if you do that, well, the reality is that the output is exactly the same. But what I've done is I've defined that if you don't give it a pressure and you don't give it a number of moles and you don't give it a Kelvin, you can still get an output. So in other words, if I said print calculate volume with nothing, it still works. Okay, 22.4133, which, as you probably noticed, was the middle number in this over here because that was the same values that were there. So I've given it default values in case you have forgotten to give it a value. Well, suppose you only wanted to change the temperature, the third argument. Well, if you notice in this case, when I called them by in the order that they were listed up here. So Pn and T were Pn and T, but the only thing that maps this number that's in the call to the function itself is the order in which it appears. What if I only wanted to define the temperature? Well, I have the ability to do that and still use those default values. I could have said calculate volume, and I can set just the temperature. T Kelvin equals, and we'll make it 350. So I go ahead and execute it in that case, and the 350 gives you 28.735. The pressure was 1. The number of moles was 1 because those were the two defaults. So what you're seeing is that your ability to define functions and your ability to call functions has a tremendous amount of flexibility. Regardless of the fact that you may or may not give it default values, and you may or may not call by actually specifying the parameters, you still want to follow these basic rules about functions. That you have a good naming convention, which usually starts with a verb, tells you what the function's going to do, and then tells you gives you a lot of detail. That you have parameters that are either easy to see and understand by the name of the parameter passed, and that the output, if there is an output, is defined, and it makes calling it much easier, and that you've got multiple ways that you can call those functions with all that. So this should help you write better functions. The biggest reason, I'll save it for last, the biggest reason for writing your functions well and in such a way that you can look back at those functions and understand what they're doing is because you are probably going to be, if you're an engineer, you're the primary client for that function. You're the one who's going to need to reuse it over and over again. And you can either write it right the first time, at which point you can go back and easily reuse that, or you can do a crappy job, which you know what that means? You're going to go back and you're going to have to go completely through that function once again just to figure out what you were doing in the first place. Do it right the first time. You do it right, you do it once. So this kind of gives you some idea of how to write good functions and how to use the good functions and a little bit more about writing and working with functions. I am not going into concepts of scope and all that in this one. I think I've got other videos that are on that, but you need to also understand when you're working with functions, you need to understand the concept of scope. Where are the variables actually defined? It's not really a hard thing to do. So between writing good functions and using functions and understanding scope, that should help you out tremendously. So anyway, Dr. Ron Eaglin out, and hope that you will now be better at writing good functions.